Today's webinar is all about simulation workflows on the 3D Experience platform. So what we can do is leverage the power of the 3D Experience platform to get our data up to the platform very quickly, run our simulations using our cloud computing, and then make our changes and everything like that. So that's what we're going to see in this presentation. Again, I am very sorry to keep you guys waiting, but hopefully you guys enjoyed this presentation. If you guys don't know me, my name is Steven Zalis. I am the simulation product manager here at CAD Dimensions, dealing with all things simulation related, whether it's desktop products, 3D Experience products, flow, plastics, FEA, basically anything in the simulation domain, you guys can come to me as a resource, questions, training, anything like that. I am your guy. My email is on the screen if you guys do have any questions lingering from this presentation, or if you guys just want to talk about anything related to, again, any of the simulation products. I'm more than happy to have a conversation with you guys. But to start off, if you guys missed my last presentation in March, I just want to quickly highlight what is 3D Experience simulation. And it's really Simulia on the cloud. If you guys are familiar with Simulia, if you guys are familiar with the Abacus products, they are another very powerful suite of finite element tools. They are world-class in terms of solver, the types of problems they can handle, the speed at which they handle these problems, and everything like that. So what we're doing is we're bringing that power to the 3D Experience platform for SOLIDWORKS users for the first time. It's fully integrated with PLM, which is Product Lifecycle Management, and our CAD systems. It functions very similarly to SOLIDWORKS PDM. If you guys are PDM customers, or if you have experience using SOLIDWORKS PDM, the interface should feel very familiar. The check-in, check-out process should feel very familiar once we start moving through the demo. But it's fully integrated with the PLM system, your CAD software. It's an add-in to SOLIDWORKS, just like SOLIDWORKS PDM is. So it should feel, again, very familiar. We have simplified applications with tools specific for each simulation domain. In this presentation, we're going to be covering the structural domain. So we're going to be dealing with finite element software, but we also have domains, which we'll see on the next slide, for flow simulation, plastics injection. We have a ton of different options in terms of simulation products on the 3D Experience platform. And again, it's fully integrated with the 3D Experience platform for easy collaboration between members of your company, members or external stakeholders. If we need to send a file to somebody, different things like that. I know SOLIDWORKS PDM relies on having a central file server. With the 3D Experience platform, everything is on the cloud. So really, your internet browser is your file server. You can get to your files pretty much anywhere you have an internet connection, which is very appealing for a lot of people, especially in today's kind of changing workforce. So this presentation, I want to cover 3 key points, or 3 key demonstrations. The first one, obviously, is to get our SOLIDWORKS geometry to the platform in the first place. So we're going to accomplish that using the 3D Experience add-in for SOLIDWORKS Desktop. So again, it should feel very familiar. It should look exactly like, or very similar to, SOLIDWORKS PDM add-in. Again, if you guys are using PDM, we are going to execute our simulations, right? It's no good just to get our geometry to the platform. We want to be able to use the simulation capabilities on the platform to make some design decisions. And from there, we're going to do a little bit of data management, right? We're going to create some revisions. We're going to transition some files through some workflows. We're going to do all sorts of stuff on the cloud using our data management tools directly inside of the SOLIDWORKS 3D Experience add-in. So before we jump in, I just wanted to update this slide. You guys have probably seen this slide before if you saw my last presentation, but we've expanded our capabilities on the 3D Experience platform even from 2 or 3 months ago, right? I did the last presentation in March, and this now has new bullet points in our list here on our platform. So we've got our structures, which we're going to be covering today. We've added durability capabilities. So fatigue, if either low cycle or high cycle fatigue is a concern, the 3D Experience platform now has the ability to handle that as well. Plastics injection, which I covered back in March, right? If we're doing any kind of SOLIDWORKS plastics work, we can certainly transition that onto the cloud if we wanted to take advantage of the cloud solver or the cloud capabilities. We have CFD, right? Our flow simulation. If you are interested in doing CFD on the cloud, if we don't need to use or maintain any of the expensive hardware infrastructure we might need for some of these high-end simulations, we can certainly do that on the cloud. We now have motion on the cloud, right? If you guys are SOLIDWORKS premium customers and you're dealing with any kind of motion analysis, there is a new role that just came out a couple of weeks ago called 3D Motion Creator that does our motion analysis on the cloud as well. We have electromagnetics. If you're dealing with any kind of radio frequency interference or we're looking to optimize any kind of electromagnetic performance, we now have CST Studio Suite on the cloud, which is another Simulia product that we can now deal with electromagnetic simulations, which is an entirely new domain that we did not have in our toolkit with the SOLIDWORKS desktop products. A lot of these other products we did have, we were just porting them over to the cloud or expanding our cloud capabilities. With electromagnetics, that is now entirely new, and we can go ahead and take a look at a new class of problems that has opened up for us. And then the last role is kind of the simulation adjacent role, where we're not dealing with any of the directly setting up any of the simulations. We'll leave those to the analysts, but we do want to do some review, do some design trade-off studies, get some pictures or write some reports or things like that. We can use the simulation review role, which functions very similarly to eDrawings. If you guys are using eDrawings desktop to view our simulation results, this is very similar to that, where we can just go ahead and pull that data down, throw it into our viewer, and we can go ahead and look at the important stuff without having to really worry about setting up the nitty-gritty of the simulation, of the mesh, of anything like that. We can certainly just take a look and get results first and worry about, our coworkers setting up the analysis. So the first thing we need to do in this workflow demo is get our geometry to the platform. And we can do that very quickly by turning on our 3D Experience add-in within SOLIDWORKS, which will look almost exactly like the PDM add-in if you guys are using PDM. Once it connects to our common space or our file server, we're going to go ahead and open up a component that has never been saved to the 3D Experience platform before. So we're going to go ahead and open up the bracket that we're going to run our analysis on. We'll take a look at our quick dimensions just to make sure that everything is correct. And then we're going to go ahead and save this up to the 3D Experience platform by simply right-clicking on the component and hitting, in this case, Save with Options. The reason I hit Save with Options is to just show this dialog box. We can create new revisions if we want to. Our CAD master is SOLIDWORKS. We're going to go ahead and save this file. We can enter a revision comment if we want, and this is saving this file up into the 3D Experience platform. Once it's up there, we can navigate onto our platform from any browser that we have an internet connection with, and we can go ahead and do things on the platform like measure our file. We can preview our file, right? I can do a search and look for my file, see if it's up there. In this case, I just want to hit preview. So this is kind of our eDrawings viewer on the platform. And we can do things like measure it. We can section view it. We can do all sorts of stuff to this file once it's on the platform. But getting it to the platform is very, very simple. All we need to do is make sure our 3D Experience add-in is turned on inside of SOLIDWORKS, and we're going to go ahead and just save it up to the platform for the very first time. So this one is the easiest step in the process, but it functions exactly like SOLIDWORKS PDM, right? You create a file in SOLIDWORKS, you can right-click and check in to check in your file to the server for the first time. This is exactly the same thing. We're just going to open it up, and we're going to right-click and hit Save to get it to the platform. Once it's on the platform, that's where the fun stuff comes in, right? We can execute our simulations very, very quickly. So we are inside of SOLIDWORKS again. We're going to go ahead and reserve this, which is the equivalent of checking out this file. And then I'm going to go ahead and use the 3D Experience add-in to activate my simulation domain. So in this case, I'm using the structural designer role and the linear structural validation, which is basically like turning on the simulation standard add-in in SOLIDWORKS desktop, right? We're activating simulation. We want to do simulation on this part. The reason I picked it directly from SOLIDWORKS is because it will link everything in the background automatically. It links the native application. So the simulation domains on the 3D Experience platform do not occur inside of SOLIDWORKS. They occur in a separate application, but they link everything to the SOLIDWORKS file. They link to our collaborative space, which is basically our vault on the 3D Experience platform. Everything gets linked in the background. So we're hitting linear structural validation because we're going to run a quick structural analysis on this part. Now, in this case, I use the structural designer role, which is kind of the base level simulation role on the platform. And I did that for two reasons. One, this simulation that we're setting up is not necessarily very complex. We'll see that in a second. But two, the structural designer role allows us to do a lot of the stuff that we would see inside of simulation standard. And I'm going to pause this for a second because we can see with the structural designer role, we get these four analysis types, right? We get linear structural stuff, so just a regular static study for you SOLIDWORKS simulation users. We can do buckling, frequency, and we can do thermal stuff, which is usually in SOLIDWORKS desktop locked behind Simulation Professional. But on the platform, the base level role, the structural designer role, gives us access to these four things. So we actually get more bang for our buck on the platform than we would using the desktop solution. The other thing we can see is that our finite element model has been inserted automatically in the background. So that is the container for our mesh. So we're going to walk through the rest of this workflow in a second. But the third reason I'm using the structural designer role rather than some of the more advanced roles is because we can create simulations in the structural designer role and then transport them or open them in the more advanced roles if we have access to all of our explicit dynamics, our high level stuff that we need to do. We can kind of upgrade those simulations as we go and start adding things to them, right? We can add things like explicit dynamic steps where we have like an impact test or a drop test. Maybe we have more exotic material models like a nonlinear material or a hyperelastic material, or we're doing a really high impact, short time, high energy event where we might need to utilize the explicit solver. We can kind of set things up in the lower base level, the structural designer role, and then import them and kind of upgrade them as we go. The one problem with that, which is why I want to point this out early, is that if you have multiple roles, right? If you have your structural designer role, so your simulation standard equivalent, and then you go ahead and open up the simulation you created in the more advanced role, say simulation premium or structural mechanics engineer, and you go ahead and save over that data, it's actually going to convert that data into something that only structural mechanics engineer can use. So if you have one kind of designer who's doing the basic simulation stuff like this, and then you have one analyst who's doing the higher level stuff, if they save over that data once it's open in structural mechanics engineer, the structural designer engineer is not going to be able to open it anymore. We can certainly open it and mess around with it as long as we don't save it, and we can kind of save without or close without saving, and then that data integrity remains intact. But if we're dealing with structural mechanics engineer, and then we go ahead and save that data, then the structural designer is no longer going to be able to open it. So it is a one-way street. I just want to make you guys aware of that because it does rewrite that data in the background, which is why in this demo, we're just going with structural designer. We don't need any exotic materials. We don't need any contacts or anything like that because this is just a bracket part. But the base level, it is a one-way street. As soon as we save it in the higher level, the base level is no longer going to be able to open it. But in this case, we've created a structural scenario, and we're going to go ahead and just walk through our setup. The first thing I'm going to do is rename this this simulation from something to something more descriptive, from physics simulation with a bunch of numbers at the end of it. So in this case, we're going to call it revision 1. And then we're just going to walk through our action bar on the bottom. The first thing I'm going to do is go to the mesh tab and just hit generate mesh, and it automatically meshes my part. In this case, we could certainly specify whatever kind of mesh we want, but this is just a first pass analysis, so that default mesh is fine. We skipped over the connections tab because this is a part file, so it's not connected to anything else, and we're going to go straight to the restraints. In this case, the clamp restraint is identical to the fixed displacement or fixed restraint in SOLIDWORKS Desktop. So we're going to go ahead and hit clamp. Then we're going to go over to our loads tab. We're going to add a quick force on our countersunk hole here of 150 newtons. And that's really all we need to do, right? We've got our force, our restraints, no connections in this case. And we're going to go ahead, and we notice that the simulate button is grayed out on our results tab. And that's because we forgot to apply a material in this case. So we could go ahead and head back to the setup tab on our command manager, and we're going to go ahead and just apply a material directly from the pool that I already have on the platform. So in this case, we can see I have about 4,500 materials on the platform to choose from. In this case, we're just going to go ahead and go with a quick 1060 alloy, just drag and drop directly onto our part, and it will apply that material on the background. So we've got everything we need for our simulation. The nice thing about the structural designer role is it actually comes with an assistant. We can right click anywhere in the window and activate our assistant, and it will walk us through. If we're kind of new to simulation or not as confident, it will say, okay, we need our materials. Our connections are optional in this case. We need at least one restraint. We need at least one load. And then the simulate button, we can go ahead and just simulate our run and get our results. So in this case, we've simulated our bracket, and we're going to go ahead and take a look at kind of our baseline results or our first revision. So in this case, we're going to go ahead and run, and we'll take a look at the different post-processing options on the platform. They are very similar to the desktop solution. The other nice thing I like about this is that our cursor is automatically a probe. We can do our sectioning right from the graphics window, right? We don't need to right click on our plot to do any kind of fancy sectioning. We can just use our context menu to section our plot however we'd like. We can do all of the stuff that we can do on desktop, right? We can overlay the mesh on top of our model, which is what I like to do to make sure that our mesh is converging correctly. We can change our deformation scale factor. We can head over, outline our model with our mesh to make sure our mesh is adequate. We can go ahead and plot a lot of different things, right? We can plot our displacement. We can plot our factor of safety. We can plot our displacement and reaction force vectors, which is a post-processing option that's unique to the platform that I love, right? Our displacement vector, our reaction force vector. We can animate everything just like we would in desktop. It functions very, very similarly to desktop. We can do our compare results. We can do our for view, right? We can drag von Mises stress. In this case, we can do displacement, factor of safety, and reaction force. We can go ahead and hit OK, and we'll give us a nice for view with the synchronization that we're used to on desktop, right? All of this stuff is very, very similar and should feel very similar to desktop. That was the goal of this whole project. We can go ahead and save this as a JPEG if we want to. In this case, I'm not going to save it because I'm not quite done with this yet. But that was kind of revision 1, or our baseline bracket, right? So we've got our geometry on the platform. We've executed our first simulation. And now we can talk a little bit about how to manage our data, right? What if I want to change something? Do I need to create a whole new SOLIDWORKS file? Do I need to create configurations? What do I want to do here in terms of comparing kind of case A to case B? And in this case, we're going to hop back into SOLIDWORKS, and we're in our original part, right? Our original revision, and we're going to make a couple of changes just to see this part update. We're going to kind of play the what if game, right? So we're going to go ahead and make our changes, rebuild our part, make our base a little bit bigger. We're going to go ahead and save this up to the platform to make those changes. And then we're going to go see how easy it is to make these changes in simulation, right? We're going to head back to our simulation application. And all we need to do is hit global refresh, because this is still tied to the same revision of our SOLIDWORKS part. So all we need to do is pull down the new version or the new changes from the server, which if we hit update or global refresh, we can see our part has updated. Our mesh has not yet, because the mesh doesn't automatically update. But if we go to the mesh tab and hit generate mesh, now our mesh has updated, and our restraints and loads, those faces are exactly the same. So those have not changed at all. We can see in our feature manager here, our material hasn't changed, our restraints and our loads have not changed. So we're all set to rerun this study, right, with this bigger base, because we didn't make an official revision. All we did was update the geometry, pull those changes down into the simulation application. Our restraints and loads, those faces did not change due to our geometry changes, so we don't have to do any changes. All we had to do was update our mesh, which took 10 seconds. And then our results are still out of date because the results are pulling the original analysis case. So all we need to do to update these would be to rerun our study. So we're going to go back to our simulate tab, hit the simulate button, let this run, update our geometry, or update our solution, I should say, update our results, and go from there. We can do the exact same comparison, right? We can do our view, we can overlay our mesh, we can change our deformation scale, we can do all of the other options that we just looked at, right? We can plot our displacement, factor of safety. We can see the factor of safety distribution has changed a little bit because there's a lot more geometry there to work with. We can change the transparency if we wanted our plot to be a little bit more transparent. We can overlay the mesh on top of our plot, which is what we're going to do here. We can do all of these different post-processing options. We can take some screenshots, save these as pictures. There's a report button right next to that compare results option. We can generate our report just like SOLIDWORKS simulation would. We can grab our view, save our view as a JPEG if we want to type up our own report, do kind of whatever we'd like to do with our post-processing options. So that's the original revision, right? This is revision 1. SOLIDWORKS, the revision naming convention is A.1, and then we go to B.1. I called it revision 1 and revision 2, but we can set the naming options however we'd like. In this case, we're going to go ahead, we're on revision A.1, and we're going to go ahead and kind of reset this back to the original geometry. So revision A.1, or revision A, is our baseline control. So we're going to go ahead and rebuild that back to our original geometry. And then we're going to go ahead, save that. So revision A is correct. And then we're going to go ahead and create a new revision directly inside of the SOLIDWORKS 3D Experience add-in, just like we would in PDM, right? You can create a new version very, very quickly. We're going to right-click our part, and then we're simply going to hit New Revision. And we're going to call this revision B.1, and we'll give this a comment so we know kind of what we did here. So we'll go ahead and revise that. And then we're going to go ahead and replace by revision, because if we see in the upper right-hand corner, we're still on revision A.1. So we need to right-click and replace to make sure we're working with revision B. So we're going to go ahead and replace by revision B. And now we're going to go ahead and make our changes, right? Our revision comment said we're going to do a taller vertical boss. So that's exactly what we're going to do. We're going to triple the height of our vertical boss to see what happens to our part. So we're going to go ahead and save this, and we're going to reserve it first, and then we're going to save it to make sure those changes stick. It's like checking it out and checking it back in to make sure those changes get written to the server. And then in this case, because this is revision B, SOLIDWORKS in the background from a data management perspective actually creates a separate file. So in this case, we're going to go ahead and update this simulation one more time, because this simulation is tied to revision A. So we're going to refresh and rerun this to get our original analysis case back. So in this case, we're doing another global refresh. Our geometry has changed back. So we're going to go ahead and generate our mesh back to the original geometry and rerun this quickly just to make sure that we have our control case. So from here, inside of the simulation domain, because this simulation application is tied in real time to our 3D Experience collaborative space or our vault, we can go ahead and grab our physical products or grab our parts from wherever we want. So in this case, we can see that bracket A1 and bracket B1 are two separate objects from a data management perspective. So in this case, I'm picking revision B, which we can see is the taller vertical boss thanks to this really nice preview. And I'm going to go ahead and create a new simulation. I'm going to create a new analysis case directly from here. The only disadvantage of having them as separate products is that we have to create separate analysis cases when we're dealing with the structural designer role. When we're dealing with the more higher level simulation domains, like the structural mechanics engineer, there is an option to replace objects by a specific revision and save all of the work that we did in our simulation. In this case, this is a simple analysis case, so it doesn't take anything to reset it up. But that is another advantage of the higher level simulation packages, is being able to replace objects by specific revisions. So we don't have to set another complex analysis case up. We can just replace with revision B and go from there. So in this case, I'm doing my material first. We're going to go ahead and check our original simulation because it's still open in a separate tab. So we're going to go ahead and check and make sure that we use the same force, right? We want to compare apples to apples. So we're using 150 newtons. I know those holes are clamped in the same spot because the holes haven't changed. So I'm going to go ahead and use my assistant, right? My setup, my materials, I've already got materials applied. So I got a green check there. Connections, we can skip. Restraints, we need at least one. So we're going to clamp these 2 bolt holes here. Give it a name so it's a little bit more descriptive than clamp.1. Our loads, we need at least 1. So we're going to go ahead and apply a force on that face in there of 150 newtons. And then we can go ahead and simulate. Now, the other advantage, once we generate our mesh here, of the simulation domains on the 3D Experience platform is the ability to use the cloud solution, right? So in this case, this analysis case, revision B, or revision B or revision 2, as I end up naming it, we're going to use our cloud computing credits. And this one is actually in real time. So this solution has not been sped up at all, right? It actually takes longer in this case to get our license from the cloud servers than it does to actually solve the simulation. The nice thing about the cloud computing option is it really lightens the hardware requirements necessary to run simulation at all, especially the complex simulations, right? In this case, the only hardware requirements we need are to be able to run this 3D Experience application, whereas we don't need a lot of complex hardware that we would need to handle a complex mesh or handle a really intense flow simulation problem. We can go ahead and outsource that to the 3D Experience servers and let them do all of the hard work, and then we can simply download the results afterwards to view them, report on them, screenshot them, whatever we might need to do. That is a huge advantage in time saving versus having to wait. Our machine is tied up, right? We don't want to do anything else because our computer is working so hard already. We can use all of that time more productively, and that job will be running on somebody else's hardware, which is really, really nice. We can do our 4 views in this case for this specific simulation, but we can also compare across simulations because I have the other one open up at the top of the screen. I can go ahead and compare case A to case B directly once I get my preview window here sorted. So I'm going to split these. So I've got 4 of them. I'm going to go ahead and make sure I'm using revision A up at the top. So I have revision A, von Mises stress and displacement. And in this case, revision B, which I haven't renamed yet, von Mises stress and displacement at the bottom. So we have revision A on top and revision B on the bottom, and the views will still synchronize across models. So we can still look at the same view across all 4, across all domains. We can go ahead and compare apples to apples. We can do our save as, right? We can save as a JPEG. We can animate this. We can do whatever we might need to do. And in this case, I'm just going to go back, do a little bit of housekeeping, and rename my really bland physics simulation with a bunch of zeros and a 1 at the end to, bracket structural revision 2. So I know exactly what I'm doing. And then I'm going to go ahead and save this to my server because the simulation object also needs to be saved, right? We've created a couple of different objects. We've created our 2 different revisions and our 2 different simulation objects that get saved kind of to our vault on the 3D Experience servers, which is our collaborative space where we can just kind of dump everything in. And then we can go from there to go pull those results down. We can use those in 3D Play, which is our e-drawings, right? We can go ahead and do all of our markups and everything like that, where anywhere with an internet connection, we can go ahead, log into a web browser, log into our platform, and go ahead and manage that data, make those changes, do whatever we might need to do to that data without having any expensive hardware or worrying about which version of our file is the most up to date, because they are always up to date, right? The 3D Experience provides a lot of value in and of itself, the 3D Experience platform. But the 3D Experience simulation tools, right, not just what we've shown today, but the flow simulation tool, the plastics injection tool, now the electromagnetics tool, allows us to create complex simulation and leverage our cloud computing power, right? We don't need any expensive IT infrastructure or any expensive hardware. We can go ahead and just grab some credits and rip through our simulations as quickly as we want to. We can communicate our ideas, our design changes, and our updates easily, all in one location, right? We opened 2 applications today. We opened SolidWorks, which we have open every day anyway. We turned on the 3D Experience add-in, and then we went to the 3D Experience application, which is the house or the vessel for our simulation setup and post-processing in this case, right? We've communicated our ideas. We brought our idea up to the platform. We made a couple design changes either in our original revision or we created a separate revision, right? We have revision A and revision B. We made our updates very easily. All we had to do was go into our simulation domain or our simulation application, hit update or refresh. It will pull down that new geometry from the server, and all we had to do was remesh to update our solution, remesh and rerun all in one location. And the big advantage that we keep preaching, right? We can manage our simulation and all of our other CAD data on the cloud. We don't need to worry about who's got the most up-to-date version, who's got access to the server. Anywhere with an internet connection, you can log in and grab your data and make it work for you, which is very, very nice, especially in today's changing work environment. If you guys have any questions, feel free to type them into the chat. If you'd rather shoot me an email, my email is right there at the bottom of the screen. I do want to thank you guys for bearing with the audio issues. I promise it won't happen again. But if you guys have any questions, I will keep the chat open for another couple minutes. Otherwise, again, shoot me an email and then enjoy your lunch, guys. I'll give you guys about 10 minutes of your day back.